Dear students, this is the 8th class on the chapter Differential Equations, and as we have started to solve second order differential equation, and in our previous class we have discussed about the solving of non-homogeneous second order differential equation, and that was part 1. And in this class we will further learn to solve a non-homogeneous differential equation, and this is the part number 2 for solving non-homogeneous second order differential equation. Now let us start and but before starting this class we need to go through these properties of d operators, some three these properties of d operator. As we already know the some properties of d operators, and here are also some properties of d operators which are summarized. And number one is that d square sine ax plus b, that is equal to function of minus a square sine ax plus b. That means in case of if we have sine ax plus b in the right hand side of the given second order non-homogeneous differential equation, in that case this f d square can be replaced by should be replaced by function of minus a square. And another one is f d square cos ax plus b. That is also seen in the similar way, f of minus a square cos ax plus b. That means in the expression of in function of d, only f d square should be replaced by f of minus a square. In so you can write by viewing these two properties that 1 by f d square sine ax plus b, that is equal to 1 by f of minus a square then sine ax plus b, providing that f minus function of minus a square not is equal to 0. This is the condition to be obeyed or to be considered. And similarly 1 by d square cos ax plus b, that is equal to 1 by f of minus a square cos ax plus b, and here also the condition subject to the condition f of minus a square not is equal to 0. So these are the properties. We learn the application of these properties to solve the non-homogeneous second order differential equation, and by using some examples, by solving some problems. Here is the first problem. Solve d2 d square by 9 or d2 plus 9y sine 2x. And from this relation, you can easily find out the values of the roots of the auxiliary equation. Here is the auxiliary equation is m square plus 9 is equal to 0, or m is equal to plus minus 3i. So the complementary function would be a plus cos 3x plus b sine 3x. And the particular integral that can be calculated from the from the relation that 1 by d square plus 9 sine 2x. And you know that in this kind of functions, that is sine 2x, sine or cos functions, you need to apply this formula, that is 1 by f. So yes, it should be f d square, 1 by f d square, that is and then sine ax plus b, that should be equal to 1 by f of minus a square, and then this sine a plus ax plus b. So this property, it should be f 1 by f d square. So here this d square should be replaced by these 2 square. So in this case a is 2. So this is equal to 1 by minus 2 square means 4 plus 9 sine 2x, that is 1 by 5 sine 2x. So this is the complementary function. So complete solution is the sum of this complementary function and this uh, particular integral. So this is done here. So this is the complete solution. This is the complete solution. Now solve another problem, that is here. Here is the equation d square plus 4y is equal to sine 2x. Okay, this is sine 2x. So to solve this, we first we find out the roots of the auxiliary equations. So the auxiliary equation is m square plus 4 is equal to 0 or m is equal to plus minus 2y. So the complementary function is a cos 2x plus b sin 2x. Obviously, and we are two arbitrary constants. Now, if we wish to find out the particular integral, then the formula should be 1 by d square plus 4 then into sin 2x. And in that case, this d square should be replaced by this 2 square with a minus sign. So if you do that, then this from this you can write minus 4 then plus 4. That is in the denominators. Uh, there is a 0. So d square plus 4. So in that case, function of f minus a square becomes 0. So this cannot be applied in this case. This formula cannot be applied in this case. So to solve this, different technique is used. That different techniques is given here. So to find out, here is written that situation, that case, that for the in the particular integral calculation, it is observable that f of minus a square is equal to 0. So we need to use another process, another method. That method is, say u is equal to 1 by d square plus 4 cos 2x and v is equal to 1 by d square plus 4 sin 2x. So from here you just write u plus iv. That is 1 by d square, this cos x, and from here plus I sin 2x. That is 1 by d square plus 4 e to 2ix. And this can be written in the fashion that now d should be replaced by this 2i, and this 2 e to the ix can be written in the left hand side, and here be 1. So e to the power 2ix 1 by d plus 2i whole square plus 4. That is equal to e to the 2ix 1 by split it. So t square plus 4id, then minus 4 plus 4 cancel out. So e to the 2ix d square plus 4id into 1. That is equal to e to the 2ix, then 4id is the common, take as common term, 1 plus d by 4i into 1. So this is equal to e to the 2ix by 4i from here, and 1 by d is this d is here, and rewrite this as 1 plus d by 4i to the power minus 1, and just expand this. So e to the 2ix, then 4i 1 by d, and expand this 1 minus d by 4i, and another also terms can be appeared here, but see here the right hand side is 1. So d means differentiation. So for the first division, this will provide you 0. So other terms of d can be neglected easily. So from here e to the 2ix by 4i, then 1 by d, and just compute this term. So 1 into 1 means 1, then d into 1 means 0. So there will be only 1 by d into 1. This is easier because d of 1, that is in differentiation of 1, is equal to 0. So e to the 2ix by 4i, d 1 by d means d inverse into 1, d inverse means integration, 1 means dx, so that will give you x. So now u plus iv is equal to x by 4i cos 2x plus I sin 2x. Just simplify it. This can be written as minus x by 4i cos 2x plus x by 4 sin 2x. And just now compare the left hand side and right hand side, and you can easily understand that b is equal to minus 1 by real and imaginary part from the left and right hand side. You can easily understand that b is equal to minus 1 by 4 x cos 2x. That is equal to, and you also know that this b was taken as 1 by d square plus 4 sin 2x. So 1 by d square plus 4 sin 2x is equal to minus 1 by 4x cos 2x, and this is nothing but the particular integral. So the particular integral, this is this. Particular integral is 1 minus 1 by 4x cos 2x. So the complete solution is the complementary function that was here, a cos 2x plus b sin 2x plus this term, that means minus 1 by 4x cos 2x. Now another problem is here, solve the differential equation d2y by dt square plus 2dy by dt plus 5y is equal to sin dt. So writing this equation in d operator form, d square plus 2d plus 5y is equal to sin bt. So the auxiliary equation would be m square plus 2m plus 5 is equal to 0, and from here you can calculate the value of m as minus 2 plus minus equal to b is 4 minus 5 into 4 into 1 by 2. And from here m has two values, m1 is equal to minus 1 plus 2y and m2 is equal to minus 1 minus 2y. So the complementary function is e to the power, since in this case it has the form alpha plus minus beta x, beta I, and here alpha is minus 1. So e to the power minus x, then beta is 2, so a cos 2x plus b sin 2x. Now to find out the particular integral. So particular integral, you can use the formula 1 by d square plus 2d plus 5 sin dt. Or from here 1 by, you know that in this case d square should be replaced by minus of this square. That is, in this case a is b, so minus a square means minus b square. So that is here minus b, this is the required formula, minus b square plus 2d plus 5 sin dt. So here, here just write this term, this term 1 by 2d plus 5, that can be written as 1 by 2d minus d square minus 5, and that from there you can write this as 2d plus p square minus 5. 2d, this should be plus p square minus 5, then 2d minus p square minus 5, this one should be plus. So this will give you y2 is equal to 2d plus p square minus 5 by, from here 4d square minus p square minus 5 whole square sin pt. That is equal to 2d plus p square minus 5. Then here you also know that in this case this d square should be replaced by this minus p square. So that is minus 4p square minus p square minus 5 whole square sin pt. That is equal to this minus sign is here, okay, 5 minus p square, you can write this equation as minus 5 minus p square, 5 minus p square minus 2d, okay, minus 2d, you can write this. So this is equal to, here see, you see here this is your minus and into sin pt, and then 5 minus p square minus 2d by 4p square minus p, just write it, just separate, just writing this with in this case it should be minus 4p square, and this write this term. So minus p square minus this should be minus 4p square, this minus 4p square will be here, okay, and after that write all the things, just you some simplify this and you will finally get, here is a okay, then you will get finally y2 is equal to minus y2 is equal to 5 minus p square sin, and just this sin pt just multiply with these terms. So minus 5 minus p square sin pt, and then 2, and different d, here is d, that means differentiation of sin pt, that will give you cos pt. So 2 cos pt with a multiplication of p, so minus 2p cos pt, and this term is here. So complete solution is y1 plus y2, this is the y1 value, that is the complementary function value here, and this, and these are the particular integral form term. Now come to the another one, that is solve the differential equation this, and in this case you just you find out the auxiliary equation and its roots. So the two roots are m is equal to minus 1 and m2 is equal to 2. So complementary function is a to the minus x plus b to the 2x, a, b both are constants. And the particular integral y2 is equal to 1 by d square minus d minus 2 sin 2x. And here you have to replace this d square by minus 4. So that is done here. So after doing that, just simplify this. So 1 by d plus 6 sin 2x. And you can write this as multiplying the numerator and denominator by d minus 6. That is here sin 2x. So d minus 6, and then with this minus sign is there, and sin 2x, and in this case d square should be replaced by minus this 2 square, so minus 4 minus 36 sin 2x. So d minus 6 by 40 and sin 2x, and then the sin 2x these d minus 6 will operate on this. So first of this 1 by this 40 is here, then d on when applied on this sin 2x will give you cos 2x into 2. This is nothing, this is not a negative sign, this has been erased, this has been erased, okay, this is not a negative sign. and then cos 2x minus this 6 and this will be multiplied, so 6 sine 2x. So finally y is equal to 1 by 20. This term is taken first, minus 3 sine 2x plus cos 2x. So the complete solution is this. Now come to the another problem. This problem is here d2x by dt square plus 2a dy by dt plus a square is equal to cos ax, and from here you can write the auxiliary equation as m square plus 2am plus a square is equal to 0, or m plus a whole square is equal to 0, or m1 is equal to m2 is equal to minus a. And then since both m1 and m2 are equal, then you can find you can write the complementary function as x1 is equal to a plus bt e to the power minus at, and the particular integral is 1 by d square plus 2 dA plus a square cos at. That is, and here this d square should be replaced by minus of a square, so minus a square and 2 dA plus a square. This is cancel each other, so 1 by 2 dA cos 80, that is 1 by 2a, and this is d inverse cos 80, that is 1 by 2a, and you know that d inverse means integration. Integration of cos 80 will provide sin 80 by a. So finally x2 is equal to 1 by 2a square sine 80. So the complete solution is the particular solution, and then this particular solution and this complementary function. So a plus bt e to the power minus 80 plus 1 by 2a square sine 80. So uh, the second part. This was the second part of solving non-homogeneous second order non-homogeneous differential equation, and in the next class we will discuss on the third part of this of solving the second order non-homogeneous differential equation.